All right, so we are going to have a quiz on the 15th. So that's a week from today on the next couple things we've been learning. Okay. Um, I think everyone took their test yesterday on the computer, submitted it. Okay. The only people who didn't were not here. So we'll get those grades to you soon. Now we're starting a section, Unit 6, on cubic functions. Okay. So are you able to, in your yellow calculator, graph y equals x cubed? Okay. So when I open my calculator, whoa, hold on. All right, so you go to your calculator and you do new document, don't save, number 2, add a graph, and you're gonna do x caret 3. Does everyone see what the cubed function looks like? It's not like a parabola anymore. It starts low, ends high, kind of looks like a weird S, maybe, kind of, not really. But sketch that on your warm up. Okay, so sketch that over here. Kind of looks like this. Something like that. And how do I get a table from here? What do I press? Control T. Yes. Control T. All right. Now, the table I gave you starts at -2, so let's go up to -2. We're going to we're going to write these points down. -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. There we go. -8, -1, -1, 0, 0, 1, 1, and 2, 8. Okay, so make sure you have that written down for your warm up. We're going to do some notes on cubic here in a second. So we're on 6.1. Here we go. So we're talking about cubic functions. We're on the section that says Introduction to Cubic and Cube Root Operations right here. So y'all know what a cubic operation is. Y'all see that little 3? X to the third power is cubic. Hey, put it away. Now, this means to multiply a number 3 times, okay? The most common error, people think cubic means times 3. It doesn't mean times 3, it means times itself and times itself. So you're multiplying the same number times itself 3 times, not just times the number 3. Here's what I mean. When I say 2 cubed, I mean 2 times 2 times 2. That's not the same thing as 2 times 3, okay? Anyways, the inverse operation of cubing, what's the opposite of cubing? Let me go and write the word opposite, okay? This is 3. So the opposite, you write that down, of cubing is called cubic root, okay? The cubic root operation, okay? We are asking what number multiplied by itself 3 times gives us x. I'll show you what I mean down here, okay? So evaluate the following cubic operations. 1 cubed means 1 times 1 times 1, which is, of course, 1. Well, let's do the second one, number 2. What is 2 to the third power? 2 cubed. What do y'all think? 8. Now, how many of y'all think 2 cubed is 6? Because you think 2 times 3 is 6. That is the common mistake. So check it out. 2 cubed means, check it out, write it down. 2 cubed means you're going to write 3 different 2s. Why is this giving me problems? Hello. I'm going to scream. Just work. Okay. 2 times 2 times. And then what is 2 times 2 times 2? 8. Okay. 2 times 2 is 4. 4 times 2 is 8. Now, what about 3 cubed? What is 3 to the third power? What do y'all think? Now, 3 cubed is 3 times 3 times 3. So 3 times 3 times 3 is not 9. 3 times 3 is 9. 9 times 3 is 27. Alrighty, lots of issues with this pen. 3 times 3 times 3 is 27, we said. Now, negative 2 to the third power. What's negative 2 times negative 2 times negative 2? What do you think? What? Negative 8? Okay. Now, if you just type it out, you get it, or if you do parentheses negative 2 parentheses caret 3, you can get it that way too. Does everyone know how you type it in the calculator? If they give you parentheses, you must use those parentheses, okay? So we get negative 8 here, okay? Okay, now, backwards. What about cube root? So what is the cube root of 1? Negative 1, sorry. So it's not dividing by 3. You're asking what number times itself gives you negative 1. Now, on all these, I don't mind if you use the calculator, you just got to know how to type it. So look, everybody, this is brand new. You don't know how to do this, I bet. You got to look with your eyes so you can see this button. Hey, look with your eyes. Hey. All right, check it out. You got to know where these buttons are. Cube root. Does everyone know where the square root button is? Right here, right? Cube root, go a little bit to the left, is right above the caret, okay? So if you want to get a cube root or a fourth root or a fifth root or any weird root, okay, it's control caret. Okay, let's go ahead and write that at the top here. Control caret. And caret is this like this looking thing. Control caret. So watch me when I press it. Control caret. Do you see how there's like a little box right here to put the cubed in? Cube root. So cube root, oops, of negative 1 gives me negative 1. That should make sense because negative 1 times negative 1 is a positive 1 times another negative 1 gives you negative 1. Okay, so that works out. What about cube root of 8? Okay, I'll give you like 30 seconds. I want you to try to, you type it in. Do cube root of 8, do cube root of 64, cube root of 27. Yeah. Why? 1. If I'm not doing those. 0. All right. 30 seconds is up. You should have done cube root of 8. And I got 2. Did you get 2? Okay, cube root, whoops. Cube root of 64 is 4, because 4 times 4 is 16, times 4 is 64. Okay. And then the cube root, whoops. Cube root, oh my. Cube root of negative 27 is negative 3. Okay. Do you see how that works? Okay. Next part. Okay, a cube a cubic root function is a function of the form f of x equals the cube root of x. Okay, now we have these variables a, b, c, and d that can modify a cube root function. Okay, but remember, a cube root and a cube function look different. The parent cubic function is, like we just wrote right here, f of x equals the cubic root of x. I can't believe how horrible this is. Okay, cube root functions, or cubic functions, sorry, have one or two roots. All right. I know we've done this in this class. What are other names of roots? X-intercept is the main one. There's two more. Root, x-intercept, 0, and it starts with an S. Solution. Very good. Those are the four phrases or four things that mean the same thing. Okay. So I know we've talked about it, run it down, right? You can flip it over, do a few more things in the back, and we'll be done. Now, on the back, okay, this is exactly what we had on our warm-up, so I'm just going to fill this in. Okay, from our warm-up, we know this is -8, -1, 0, 1, 8. Okay, this is our parent function, x cubed. Can you plot those points, though? So instead of just a random sketch, plot those 3 points on that graph. Okay, -2, -8, -1, -1, 0, 0, 1, 1, 2, 8. So everyone's plotting those points, right? Hey, plot those points. And then do your best to make a nice cubic looking function. All right. And then we can do the next one. Go to a new document, don't save, number 2, add a graph, and put 2x caret 3. Okay. And again, to get the table, we press Control T, and I'm gonna go up to -2, and I can write these numbers down. -16, -2, 0 to 16. Shows it right. Okay. Now, when you're plotting these points, the 16s are like off the grid. So just plot the ones you can plot. So -1, -2, 0, 0, and 1, 2. Just do your best to make a nice cubic function. Okay. That should look a little bit more stretched vertically. And that should make sense because 2 is greater than 1. Vertical stretch. Right? And then same thing here with -3 x cubed. And then this is supposed to be -3 x cubed. All right, so we can do a new graph of that one. -3 x caret 3. And then Control T again. And we can plot these points. -2, 24, -1, 3, 0, 0, 3, 1, 3, and 2, 24. -3, sorry, and -24. Again, these points, 24s are like off the grid, but let's plot the ones we can. -1, 3, 0, 0, and 1, -3. All right. So that one's even more vertically stretched, and because of that negative sign, it looks like it's done this thing, where it flips over. What's a better math word for flipping over? Hey. Starts with an R. What do you call it when it flips over? Reverse is kind of rotation, yeah. Or better yet, reflection, sorry. Reverse, rotate, reflect, all related, but okay. Does everyone have those three plotted with the tables? Okay. Actually, move that. Holy moly. All right, then we're gonna move the right side of that page. Okay, here we go. All right, when A is greater than 1, so hopefully you noticed when the number out front is greater than 1, it does this. We call it a vertical what? We've done this every section. Vertical what? Stretch. Okay. So if it's less than 1, that would be a vertical compression. What if A is negative? Okay, that's what do we say happens to it? It flips it or it reflects across the x-axis. Reflect across the x-axis. Okay, now I'm about to show you all the easiest part of this, domain and range. Look at this picture to the left here. Doesn't it go forever to the left, forever to the right? Doesn't it go forever down, forever up? Okay, since there's no stopping it, you don't have to even think what numbers are there. It's literally from negative to positive infinity, okay? So you could write it like this, negative infinity with the parentheses, comma, to a positive infinity with the parentheses. Or you can just write it with the weird looking R. Have y'all seen this R before? I mean, all real numbers. That's an abbreviation for both infinities, okay? I'm telling you, this section, your domain and range is gonna be very easy. It's always gonna be that, okay? Now you don't have to write both of these, just pick one. If you like the infinities, do that. If you like the weird R, do that. Cool. Okay, now here's the deal. When you're doing this, oh sorry, let's answer this last question there. How is the range different from the range of a quadratic? Okay, if y'all remember the range of a quadratic, like it would like stop at the vertex and change. Okay? So this one does not stop. It goes forever, both directions. That's the big difference. Now a critical point occurs when the graph changes directions, okay? A cubic function has at most 2 critical points, okay? Now, if you remember with a quadratic, it was a vertex. So basically they're like little vertices. It's a little maximum and a little minimum at most, okay? The way you get those is by doing menu 3-1. You can see those maximums and minimums, okay? So again, max slash min when you're doing menu 3-1. What's up? Okay, so we have another equation to graph down here. So let's go ahead and graph this one. It is x cubed, so x, okay, x caret 3, go to the right, plus 2x squared, plus x minus 3, okay? Now, y'all see that graph right there? Do you see how it goes up and it kind of makes it like a little top of the hill? Then it goes back down, little bottom of a U, and it goes back up. Those are called my 2 critical points. One's a max and one's a min. So let's go ahead and first do Control T to get some points. -2 is -5. -1 is -3, 0 is -3, and 1 is 1. Okay. So let's plot these points: -2, -5, -1, -3, 0, -3, 1, 1. As you can see from the graph over here, it's going to go up, go back down, and then back up again. So it's going to go up, down, and then up again. I know it's kind of hard to see there. So to get these critical points, I need to do menu 5-1. Y'all remember menu 5-1? You can trace it to get the vertex or a max or a min. So in this case, I got a little max right there. So let's go ahead and write, there's a maximum at -1, -3. That's this point right here. And if I go to the right a little bit more, I get a minimum at -0.3, comma, -3.15. Okay, do you see how those are called critical points? Because they are where it changes direction at a max or a min. Okay. Now tomorrow you'll have an assignment for this. Keep these notes. Right now you can work on finishing 5.4, 5.3, 5.2, 5.1, anything that's missing. Okay. Cool. Let's hold on to this stuff.